Hello, I'm the awesome tutor, and today we're going to be looking at the basics of Suvat. Now, Suvat, what does it stand for? The S stands for displacement, measured in meters. It does not stand for distance. Distance is a scalar quantity which measures only magnitude. Displacement is a vector quantity, and so it has both magnitude and direction, meaning it can be positive and negative depending on the direction. Same thing with the velocities. They can be both positive and negative because they're both magnitude and direction. They're not speed. So U is initial velocity, V is final velocity measured in meters per second, and A is acceleration measured in meters per second squared, and T is time measured in seconds. Now these are the Suvat equations you need to know. Depending on your exam board or what exam you're taking, you either have to memorize them or they'll give it to you in a sheet. So V is U to the plus AT and S is blah 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 blah. The common ones you need to know is this one, this one, this one, and this one. This is not so common and not used as often, but it may still come in handy. So you still need to learn all these equations. They need to be stuck in your head. And Suvat only applies, these equations only apply if what you're talking about is moving in a straight line with constant acceleration. Otherwise, the Suvat equations are not going to work. So let's move on to a practice question. Okay, a train is moving along a straight horizontal track with constant acceleration. Straight horizontal track, constant acceleration. When you hear the word straight and constant acceleration, you know it's a Suvat question. So the train passes a signal at 54 kilometers per hour and a second signal at 72 kilometers per hour. The distance between the two signals is 500 meters. Find the acceleration of the train in meters per second squared. And the first thing I would do is draw a diagram like this. So here's the first signal, here's the second signal, the distance between them is 500 meters. When the train reaches the first signal, it is at 54 kilometers per hour. Convert that into meters per second because you want the acceleration to be in meters per second squared. So make things easier for yourself. So times by 1000 divided by 60 twice, same thing for 72 kilometers per hour. You get 50 meters per second here and 20 meters per second here. So convert the values. And then you write Suvat and you write down the values it gives you. Do we have the displacement from one point to another? Yes, we do. It's 500. From the first signal to the second signal. Do we have the initial velocity? Yes, we do. 15 meters per second. Second and final velocity is, yes, 20 meters per second. And what we're trying to find is the acceleration. So we need to find an equation, one of the Suvat equations, that uses both S, U, V, and A. The one I'm going to use is V squared is U squared plus 2AS. The more you practice, the easier the equations will come to you. So, if you put these values in, and you do some number crunching, you will get the acceleration is 0.175 meters per second squared. Now let's move on to the next question. Okay, so the driver of a car is traveling at 18 meters per second along a straight horizontal road when he sees an obstruction ahead. He applies the brakes, slowing the car down to rest with constant deceleration 3 meters per second squared. So, constant deceleration and along a straight horizontal path, so it's a Suvat question. Now I want you to find the distance traveled as the car decelerates. So here's the diagram. First it's at 18 meters per second, then it decelerates to rest, which means if it's at rest, its velocity is 0 meters per second. And here is the acceleration, which is minus 3. It says the deceleration is 3 meters per second squared, which means the acceleration is minus 3, negative 3, because it is the opposite of deceleration. So it is going, if you draw this, then you could say 3 meters per second squared, because it's in that direction that it's decelerating. And here, it's in this direction, but it's decelerating, so it's negative. Okay? So if it says deceleration is something, the acceleration is going to be negative. That's all you need to know. So here are our values. Now the equation I would use is V squared is U squared plus 2AS. Do some number crunching, and you get S is 54 meters. That's the distance traveled by a car as it decelerates from this point to this point. Now the second thing I want you to find out is the time taken for the car to stop. So let's rewrite our Suvat values. So now we have only one unknown. We can use any of these 4 values. Now we have a wider selection of equations to use. But supposing you got the answer wrong for A and S is not 54, and you use that value in another question, part B, you're going to get that answer wrong too. So always try to use only the values the question gives you. That way if you get this wrong, you can get B right, if you don't make another mistake again. So the equation I would use in that case would be V is U plus AT. Do some number crunching, you get T is 6 seconds. Now onto the final question. Particle P is moving on the x-axis with a constant deceleration of 2.5 meters per second squared. When time is 0, P passes the origin O, moving in the positive x direction with speed 15 meters per second. So I want you to find A, the time between the instant when P first passes O and the instant it returns to O. What? Returns to O? How the hell does it reverse? Well, let me explain it to you. Diagram. So here's particle P when it first passes O with speed 15 meters per second. Here's the x-axis, O, and the point when it starts to go in reverse. So this is the positive x direction. Now, if you imagine, because it's going at a constant deceleration, so accelerating minus 2.5 meters per second squared, the speed is therefore, the velocity is therefore going to decrease, yeah? Because it's decelerating, the further it moves, the more the velocity will decrease, yeah? You got that? Okay. So it's going to reach a point where it's decelerated so much that it's come to rest, okay? Decelerating, 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 then stop. And that point is when it has a speed, a velocity of 0 meters per second. But if it continues to decelerate, what will happen? It will go below 0. So it will have a negative value for velocity. And because, remember I said velocity is magnitude and direction. So now it's moving with a positive velocity, but decreasing, decreasing, decreasing to 0. When it reaches 0, it still decelerates, so the speed, the velocity, becomes negative, goes below 0 as it continues to decelerate. And because it's negative, here's the positive direction, so the negative direction is this way. So when it becomes negative, when the velocity becomes negative, it starts to go back along the same path. And this point A is when it reaches 0. The instant it starts to go in reverse, when the velocity becomes negative, the particle returns. So hopefully you got that. If you didn't, rewind and listen again. And now we're going to move on to actually solving the question. Okay, so here are the values we do have. The initial velocity, 15 meters per second. The acceleration, well, it gives us the deceleration, so the acceleration is going to be negative 2.5 meters per second squared. And the time between the instant when P first passes O and the instant it returns to O. So if you imagine, here's the starting point. The displacement, remember displacement is also a vector quantity. It's not distance, it's displacement. So the particle goes here, 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 here. The displacement from O is going to increase. But as it returns to O, the displacement is going to decrease. It's going to get closer to O, so displacement is smaller. When it goes back to O, displacement is 0. Its displacement from O is 0. Okay? The distance traveled is a different thing. Distance traveled is this add its return journey. Okay? Because it's just magnitude. There is no negative. Okay? Displacement increases, displacement decreases. Back to 0 from the original position. So that's why displacement is 0. And with this, you can work out what the time is going to be. So the equation I'm going to use is S is ut plus a half at squared. Do some number crunching, you will get. So as you can see, it turns out to be quadratic, and your two answers for t is 0 seconds and 12 seconds. Why? Well, you put in the value of displacement is 0. So it is the times when particle P is at O. T is 0 is when it first passes O, so it is at O at that time. When t is 12 seconds, it is when it returns to O. So that's why you have two values. When it first passes O, then when it returns to O. Now move on to the second part of the question. So it wants you to find the total distance traveled by P during this time. Now it says distance, not displacement. So you can't do what you did in the first question. In the first part of the question, you looked at this as a whole journey. It going there, from O to A, then back from A to O. Okay, because in the first part of the question, it would have been more difficult and more complicated if you just did this journey and this journey separately. You will mix up your calculations, you will mix up your directions, blah, 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 blah. In this part of the question, you cannot take it as one whole journey because it's the distance traveled. If you use displacement as 0, you will not get the answer. Okay? Distance is going to be how far traveled from O to A and how far traveled back. So this and this. It's distance, not displacement. So let's find our values for Suvat. So to solve this question, we have to find the displacement from O to A and then just double it. That's the easiest way to solve it. So let's find the displacement from O to A, and whatever answer we get, we'll double it. So O to A, then back again. So first it starts at 15 meters per second, that's the initial velocity. At A, it's 0 meters per second. That is the point when it starts going in reverse. That is the instant when the particle stops moving. And then it goes back because velocity becomes negative. Acceleration still constant, minus 2.5. And time is 6. Why? Well, we found out that in the first question that the time of the whole journey is 12 seconds. So we're looking at half the journey now, then we're going to double it. So that means we're going to have to half the time. 6 seconds. From O to A, it's 6 seconds. And A to O, 12 seconds. But as I said before, try to use only the values the question gives you. Because that way, if you made a mistake in the first part of the question, you don't want to make a mistake in another part of the question. So imagine the value for t you got was wrong. You're going to get this part wrong too. So just use the values the question gave you. So the equation I'm going to use is v squared is u squared plus 2as. This number crunching, you will get the displacement from O to A is 45. Now this is just me using the value of t, so using another equation. That's only if you are 100% sure that the value you got for t was right. And here it's supposed to be 6 because we're looking at half the journey now. But it wants you to find the total distance traveled. So we only found half the distance traveled, we double it. Our answer is 90 meters. Those are the basics of Suvat. Obviously there's more complicated things like gravity, where the acceleration is minus 9.8 or positive 9.8 depending on which direction it's going, and they've got up an inclined plane, but those are for another video. So this has been the Awesome Tutor. Bye.